Good morning. I am Dr. Vidya from St.Joseph College of Arts and Science, Cuddalore, PG and Research Department of Computer Science. Today we are going to see the compiler design. Code generator in compiler design. Code generator is a crucial phase in compiler design responsible for transforming intermediate representation of source code into target machine code or assembly language. This phase takes the optimized intermediate code and produces low-level architecture-specific instructions that can be executed directly by the hardware. Code generator converts the intermediate representation of source code into a form that can be readily executed by the machine. It is expected to generate the correct code. Designing of the code generator should be done in such a way that it can be easily implemented, tested and maintained. We are having two descriptors. One is address descriptor and register descriptor. An address descriptor used to represent the memory locations used by a program. These are created by the getRegister function, which returns a structure containing information about how to access memory. Address descriptors can be created for any instruction in our program's code and stored in register or in the stack. However, only one instance of an address descriptor will exist at any given time unless another thread is executing. Another one is register descriptor. Register descriptor or data structure that store information about registered used in the program. This includes the registration number and its name along with its type. The compiler uses this information when generating machine code for our program, so it's important to keep it up to date while writing the code. Role of the code generator. The code generator plays a central role in translating high-level programming constructs into a sequence of machine instructions. These instructions are typically optimized to minimize execution time and restore and resource consumption like CPU cycles and memory usage. What are the key functions of the code generator? We are having the key functions: instruction selection, register allocation, instruction scheduling, address calculation, handling function calls and control flows. What are the stages in code generation? Intermediate code to the target program, register allocation and assignment, code optimization and final code emissions we are having. And for example, the workflow, we are having one high level code, integer a is equal to 5 and integer b is equal to a plus 3. We are going to write the intermediate representation I or t1 is equal to 5 temporary file, t2 is equal to t1 plus 3 and b is equal to t2. And we are having the target machine code that is called the assembly language. First we are going to write move r0 #5, that is load immediate the value of 5 into the register. Next add r1 comma r2 #3, that is add the value 3 in the register r0. Store in r1, finally the value store in r1. Move b comma r1, that is move that result value to the b register. What are all the challenges in code generation? We are having the optimization complexity, target architecture specificity. A balance must be struck between the generating efficient machine code and keeping the complexity of the code generation process manageable. Target architecture specificity. Code generator must be tailored to specific architectures, for example, x86 and ARM, and handling the multiple architectures add to the complexity. Register spilling. If a program requires more register than are available in the CPU, the code generator must decide which values to store in memory and when to reload them. Conclusion. The code generator is a vital component of a compiler that transforms intermediate code into the executable machine code. It performs tasks such as instruction selection, register allocation, and instruction scheduling to ensure efficient execution of the target program. The effectiveness of the code generator directly impacts the performance of the generated code on the underlying hardware. Thank you. Thank you, one and all.